Hey, what's up everybody? Welcome back to another Layer by Layer. This is the live edition. Happy Friday everybody. It's Pi Day. So today we're going to do some CAD. We're going to take a look at a new Pi project and get started. Yeah. So let's take a look here. I'm going to jump right here and start talking about this. So Todd Treese is a software engineer at Adafruit that works with us, and he started this project using a Raspberry Pi Zero and the NPR One API to make a sort of standalone NPR One streaming radio. So he developed a couple of different things, and here are some of the parts for the project. And I think what would be actually better is if I just demoed it to you now and showed you the components in it. So he sent this out to me. This is sort of his prototype. This is an Adafruit box. And you can see that there's a couple of pieces of copper tape. We'll get to those in a minute. But inside the box, there is a Raspberry Pi Zero, and it's connected to a Promo Proto PC with a couple boards. It's got an amplifier, a speaker, and a capacitive touch breakout board. So what's going on here is that we have a couple of these pieces of copper tape that are wired up to the cap touch sensor board, and that acts as a play, stop, next, and previous, and a favorite or interesting button. So if I hit play here,
we've all heard about the bullying that can take place online. We're now going to hear from a woman who is shining a light on the abuse she has experienced herself.
So there's some interesting stories going on, and right now it is connected to my Wi-Fi network, so it's pulling an audio feed from the NPR One app, and it's a nice little standalone radio. So I can hit the next button and it'll download the stream and start playing it through. So it can be standalone. It's got its own amplifier. Right now I'm powering it through just a 5 volt power supply is plugged into my wall outlet. And it's just plugged into the Pi here, and that's how that's working. So again, shout out to Todd Treese who put the software together. It is up on GitHub. Here's the link to it. I think it's going through some updates and things. There's a little bit of fine tuning to do to it, I believe, but it is available now or will be soon. But the point of this tutorial is to take the components, take it out of the sort of prototyping phase, because it's although you could use a box and it works okay, we're going to permanently sort of lock it down to a 3D printed enclosure. So if I go over to my CAD, I'll actually kind of preview what I have going on with it so far. So this is sort of the concept that I came up with. It's just a simple enclosure, and what I plan to do is actually mill out the top cover in wood, in cherry wood, using a desktop CNC machine, the other mill. So the top just has the NPR branding sort of etched into there. It's sort of extruded out, and it's three-dimensional a little bit. And it's just going to be like a top cover, and then in the inside is going to have all the components. And this whole frame is going to be 3D printed in any type of plastic. We can use ABS or PLA, but I'm thinking to sort of combine it with with wood. We have a composite PLA that's mixed with wood fiber, so it's wood fill. So we can probably use that, and we're going to try to not use so many screws, so I can 3D print these standoffs that are sort of merged into the bottom of the case. And the cool thing is to do the capacitive touch buttons. We actually have PLA, conductive PLA material from the folks from Protopasta, and we've done a couple tests with it, and it works pretty well. So I think it'll work, because we can 3D print these buttons out using that PLA, conductive PLA. And then we can wire that into the cap touch board. We could probably use, we wouldn't solder to it, we'd probably use something like bare conductive paint or something similar. And then that way we can just touch the buttons, and they won't have to be like actual mechanical buttons. They can just be like touch sensed. So that's pretty neat. And I think that's all that I have planned for it. In the back here we have a couple of ports. So I'll be able to plug in some peripherals to the Raspberry Pi. If I want to plug in a keyboard, or if I want to plug in a monitor, I can make another porthole for the HDMI port. And then to power it, to make it portable, we can add a battery. There's enough room here for another battery. And then this component here is the PowerBoost 1000C, which can regulate any like a 3.7 LiPo battery. It can regulate it up to 3.5, and then or at least boost it to 5 volts, and then that can be connected to the Raspberry Pi. And it also has a charging circuit built in, so if the battery dies, we can just plug in a power source using a micro USB cable and charge the battery. So there's the speaker here. Here's the Perma Proto board, and the Raspberry Pi, and of course the power boost. So I've already gone ahead and modeled all the components, but what I want to do in this tutorial is show you guys how to bring components in to Fusion 360 sort of as a blank canvas, and then bring them into my canvas, and then show you guys how you have a little bit of flexibility if you model it in a certain way. You can sort of adjust and move components around, and then get your standoffs and things sort of updated with the components when you move them around. So I'll go ahead and do that now. I'll start importing in some stuff. So if you just right click on your components, you can just import them. So you can say insert into current drawing, and that'll insert that into your drawing. It'll insert it as a linked object, so that if you update it outside of the project, you can update it inside this sort of master assembly. And I'll import the speaker. Same thing, insert into current drawing. And it'll just place it on the grid wherever you modeled it. I try to keep things in the center for the most part, but for this particular one, I think I started sort of like how EagleCAD starts it on the lower left corner. So I have the speaker there. And when I first started this project, it was just sort of like, I'm not sure where the components are going to be, but I'm just going to insert everything and then just kind of move them around, make a standard, not a standard, but just make sort of a box enclosure, and then move it around. But I learned a couple things that I wanted to share with you guys while doing that. So once I get all these components in, I'll model an enclosure around the components, and then we can and then I can show you how you can move the components, and then the enclosure will get updated. Okay, so this is the NPR cap touch sensor I'm importing here. And they're pretty simple components. They don't have too much going on with it. It's just a board with standoffs. And the way I got the measurements for the board is since these are all open source components, I just downloaded the EagleCAD files and then ran a couple of dimensions using the dimension tool, and then just inputted that into Fusion and extruded out a little board. So that's pretty much what I did there. Almost done. We're still importing. And my computer's going a little bit laggy. I'm trying to stream at 1080, and I think that's killing my poor little laptop here. That's an okay spot. We'll move it later. And I think that's all of them. But that. Yep, I think that's it for now. Okay, so the first thing I want to do is actually move some of these components. Since we're using a Perma Proto, it's a prototyping PCB board, which is basically a breadboard, but with it's basically a breadboard, but as a PCB, as a printed circuit board. So you can see that the amplifier is the red one here, which is actually a prototype, and the blue one is the cap touch sensor. And they're just soldered on top, and then the wires are free wired into the Pi's GPIO header. So instead of using like mounting screws to mount each individual component, I could just mount this entire perf board to the enclosure. So that's what I plan to do. So there's already 2 mounting holes, so that's what we're going to use. We're going to use those 2 mounting holes. But just for the sake of sort of clearances and things, I thought I would go ahead and model the 2 boards, the cap touch and the amplifier as well. So now I have everything in here. You can see in my timeline, it's recording when everything was imported. So at this point, let's see if I can get my tools back here. I should be seeing my tools, but I don't see them. Give me a second here. I think my computer may have borked a little bit. I'm not able to, usually there's like a toolbar up here, but I think because of either streaming or something has stopped my tools from showing up. So thankfully I can reach everything through this magic menu inside of Fusion. So if this bug ever happens to you, you can use the right click to get to all of your tools. Usually there is a giant toolbar at the top, but for whatever reason, I think it's because I'm streaming. It may have, Wirecast may have messed with my Fusion a little bit. So, ooh, it's really, really slow. And I'm not sure I can select anything. Hit move, and I can't select anything. Uh-oh, we might have a problem, folks. I may have to restart Fusion. Let me give it a quick save here. Maybe that'll bring it back up. I'll go ahead and close the design and open it up again. Hopefully that helps it out here. I'm just going to wait for that to finish saving. There is a scheduled maintenance that's happening Monday, so I wonder if that might be something to do with it. Let's see here. Move. Yeah. Move components. There we go. Okay. So I had the object selected, and of course these are objects, but they're actually components because I imported them in as a component. So that's what was happening there. But still, I don't have my beloved toolbar, so I might have to restart the app, but just to save you guys a little bit of time, I think I'm just going to deal with it and start using the sort of right-click magic floating menu thing. So it's very arbitrary how you want to lay out your components. You can lay them out in any way, but with some considerations of what you actually want access to. If there's some ports that you want access to, in this case, I really want to be able to access the USB port from the Raspberry Pi. There's a power there's 2 micro USB ports, one for power, one for peripherals, and then an HDMI port and then an SD card port. So depending on your project, you really want to consider what do I want to have access to, and when you want those ports accessible, you kind of want them near the edge of your enclosure. So that's what I want to do. I want to kind of have it in a certain spot. So let's say all of these components are in the right spot where I want them, and I want to start drawing out something. So I'm going to go to Sketch, and then I'm going to go to Rectangle, and it's going to ask me some components have been moved. And what it's basically saying is, do you want to continue in the previous position, or do you want to capture the position of all the components? We want to capture the components. So what that's doing is it's making a marker in your timeline saying, this is the point where all the positions of every component is saved. So that's very helpful. Excuse me. So now that I have the rectangle tool open, I'm just going to click on this plane here, which is like the ground plane. And then I'm just going to, usually I have you can draw on the grid here to get snap fit measurements. Usually I like to type in numbers and get an exact dimension, but for this case, I am not going to do that because it'll give me free range of freedom. Let's say I move the components later. I can come in here and just sort of drag this sketch out. And since I'm going to use this sketch, it's a good thing that it has that free the degrees of freedom. So I'm going to go ahead and hit stop sketch, which gets me out of that environment. Man, it's really weird to not have a toolbar up here. So the next thing we can do is extrude this out to make the box. And what I'm going to do is I have a couple of hotkeys set up that's sort of default to Fusion. If you hit E on your keyboard, when you have a face selected, you can extrude things out. So I'm going to extrude this out. I'm not sure how tall yet, but we can. It doesn't matter because we can always change that value after the fact. And it's a new body as the operation, so I'll hit OK. And then in my sidebar here, my browser, I'll have this new body called body 1. So I can't see through it yet. That's okay. We can either apply some section analysis to it, where I can cut through this and see through it, or I can apply a sort of a glass material so I can see through it. So right off the bat, one thing I need to do is I need to move these components up. I could move the box here, but since I already have a sketch driven from this, I'm actually just going to move the components. So if I double click on the position on the captured thing here, it'll take me back in time, and then I can just move everything up. So that's what I'll do. I'll right click, go to move, and then it's set to object, which is what we want. Click on that. Click on something. There you go. It's very, very, very slow. I'm amazed that my computer hasn't crashed yet. Next time I am definitely going to stream at 720p or get a new laptop when they come out. So I'm going to move this up a little bit so it's not touching the bottom of the enclosure like it was. I don't know, I think 5mm is okay. Again, we can modify this change. I'm going to hit OK. And I don't have an accept. Oh, yeah, I do. Right click and hit finish capture position, and I'll hit accept position edit. Man, that is really nice that Fusion lets you access everything through the right click menu. I don't know what this is called. It's like a magic menu, right click menu. You invoke it by right clicking anywhere, so you don't have to go up here in the toolbar. And again, in this case, my toolbar is gone. I'm not sure why. So now that it's moved up there, my playhead here, my what do you call it? They call it something. This sort of playhead, you can move it around and scrub through the timeline. So right now, when I hit capture position or save position, it just brought me forward to when I did do that extrude and did the sketch. So now at this point, what I want to do is I want to cut a top off of here and then create a shell. And the shell will hollow this out so I can see through my components. But before I do that, I'm going to add some fillets by hitting F on my keyboard. And I'm going to select these edges here. And that's just for aesthetics reasons. I like adding fillets before doing anything to the enclosure. So I don't know, put something like 6, maybe 10. Some nice round edges. I'll hit OK. And then I'll even add a nice round edge to the bottom. Same thing. Hit F on my keyboard, click on your edge, and then insert or type in a value. In this case, you have a little floaty menu. Sometimes the floaty menu doesn't work. So you can do that or type it in here. Hit OK. And I'm going to keep this straight edged because since I'm going to mill this out of wood, I kind of want that to be straight edged. So now the next thing I'm going to do is I'm going to create a construction plane, and that is under construct, and it's the first one here called offset plane, and it's going to let me create a plane based off of a surface. So I'm going to click on this plane here, and I'm going to drag it down by 3mm, and that just pushes it down there. So when I hit OK, I can use this to construct different features. So I'm going to go to modify, and I click on split body, and this is going to, like it says, split the body. So I'm going to select this as the body, and then my splitting tool will be that plane. So it gives me a sort of a red indicator here, a little red circle, and that says I'm going to cut this here, and I'm going to say OK. And then if you look at the body, your bodies in the browser, you can see you have two bodies now. So you have your top and your bottom. So the next thing I'm going to do is I'm going to hide the constructor space. I don't need them right now. And it makes a new folder for you. So that's really nice. So you can access them or hide them as you want. And then I'm going to click on this surface, right click, and I don't see, oh, there it is, shell. Awesome. So I can click on shell, and then shell, like the name implies, is going to shell this out, and then you can insert a thickness. It's an inside thickness. You can change it to outside or both. I'm going to keep it on the inside, and I'm going to make it 1.5 millimeters. So it's not too thin and not too thick. So hit OK, and you can see with one click, I have made a box, a hollow box, which is awesome. So that's good. Now, if I wanted to cut through this and see through this here as I'm working on it, because I want to create standoffs for those mounting holes, I need to be able to see through this. So there's a couple different ways you can do it. I could apply a material like this. Right click, hit physical material, and then one of the materials is glass. You have a bunch of different ones here. Here's glass, and I just drag this out of the browser and then just drop it onto whatever, and you can kind of see through it, and that works. I'm gonna put back steel just to show you the sort of the better way to do it. I'll right click here, and it's going to be under inspect, and then it's called section analysis. So I'll click on that. And then it tells me select the surface, or face rather, and then I click on this face, and then you get this manipulator, and then if you pull this out, it'll actually cut through your the whole assembly really, and you have a little, you have some X, Y, and Z input fields where you can add a specific value, but I don't really need a specific value. I just kind of need to sort of see in it and see how much clearance I have from the bottom of the enclosure to the bottom of the components. So since I made it a 1.5 millimeter thick enclosure, I moved the components up about 5 millimeters. So it's really, the clearance here is about 4.5 or really 3.5 millimeters. So that's probably okay. Since I look at the bottom here, there are just a little bit of bits here. It's not completely flush on the bottom of the components.
A presidential candidate.
I hit the play button. That's kind of funny. I was just trying to look underneath the boards to make sure there's nothing there. But it's good practice to have a little bit of clearance under there, so the boards aren't completely flush on the bottom of the enclosure. Okay, so the next thing I'm going to do is I'm going to turn off section analysis for now. And at this point, I can start adding some things, but let me show you real quick. If I bring back the sketch from the sketch panel, you can see I'm able to move it. So if I drag one of the corners down and I move it, it'll actually update everything that I've done to the enclosure. So I have this sort of degrees of freedom. So if I'm still trying to iron out the positioning of the components, I can always go back and modify things. Now that's free-form way to do it. When you're moving it in sort of this sort of free-form canvas, it's not snapping to the grid. If you wanted it to snap to the grid, or if you wanted to start adding some constraints to it, you have to go into the edit mode of it. So you can either right-click on it or double-click on it and hit Edit Sketch. And then you're back in that editing sketch environment where you can add specific constraints. You have a whole slew of constraint tools to mess with here, which is really nice. Or you can add dimensions and constraints so that when you move things around, it'll sort of retain those constraints or whatever rules you apply to it. So I'm going to hit Stop Sketch here. And I'm going to start drawing out some standoffs. So standoffs are what's going to keep these components mounted to the enclosure. And I'll hide this body 1, and I'll hide sketch 1. And let's say I want to start making standoffs for the Perma Proto board, this guy over here. So what I can do is I can right click and go to sketch, and the standoff is going to be circular. So I'm going to go into the circle, and I'm going to hit center diameter circle, and it's telling me what plane or what surface do you want to start sketching on top of. I'm going to sketch directly on the bottom of the PCB here, this board. So I'm going to click on that, and what Fusion is going to do is automatically trace all of the features, all the edges that are pertaining to that board or that object. So you can see here, it already knows that there is a center point of the mounting hole here. So that little circle indicates that there's a center point. So I can click on that, and then when I drag out, I can either freeform draw it, or I can type in a number. In this case, I'm going to type in 6, hit enter, and then I will do the same thing over here. So hit C on my keyboard. That's a quick shortcut to get to the circle tool, and I'll hit 6, hit enter. And now I'm going to hit, that's really all I need from this, since the standoffs are just going to be cylinders, and this center mounting hole is already copied or traced, projected. I don't need to draw it again, so I just need this sort of outer thing here, and that's what's going to keep our board elevated from the enclosure. So I'm going to hit stop sketch, and at this point I can start extruding these things. So I'm going to hit E on my keyboard again as the hotkey, and I'm going to click on these two, and then these two at the bottom here. And then you can see the extrude lets you do a direction. The operation is set to new body, and the extent is set to distance. So if I start dragging this out, you'll see it starts extruding out those cylinders. If I bring back body 1, which is like our main enclosure piece, it'll automatically change the operation to cut, because that's sort of the default behavior. But what I want to do is I want to make it join, so it joins to this enclosure, and I'm going to change the extents to 2, and 2 allows it to be dynamic. So if I ever change something, it'll say wherever this surface is, I'm going to follow that surface. So I'm going to hit OK. You sort of can't see it yet, but if I click on section analysis, the thing that we set up a little bit earlier, I might be able to see it if I go over here. Yep, you can see the little cylinders are there. Now the next thing I'm going to do is I'm going to extrude upwards. So I'm going to bring back sketch 2, which is our standoff sketch that we projected on the bottom of this PCB. I'm going to highlight that and click E, or press E on my keyboard to bring back that extrude command. And I'm going to painstakingly rotate around the model and then click on the second circle. And I'm going to move up here, and I'm going to bring it out by about 2 millimeters. And the thing is that it's set to join automatically, so it's going to join to those two standoffs, but it won't join to the component because the component's standalone. So that's a nice thing. And the operation's already joined. The distance, I do want it to be a distance. There's no 2 that I can select to. I could select to the top here, but I kind of want it to be coming out a little bit more than the PCB, so I'm going to hit OK. So with these pegs on top, if I hide the board, the Proto board, you can see that's all it is. And I'll hide the sketch too. And you see that's all. So when I print this out on my 3D printer, I can just lay the board and it'll snap fit into those little pegs, because the pegs are the exact same size as the mounting holes. So that's nice. And I could start doing the same things to all of these components, the same workflow. You just start drawing a circle. You click on the bottom of your board or your bottom of your component, like in the case of the speaker, and then extrude upwards, join it, make it go 2. And now what I want to do is, let's say I want to elevate this bigger, I want to move it somewhere, right? So let's do that. Let me show you what happens when we do that. So I'm going to turn off the selection analysis. I'm going to bring back the Proto board since we made standoffs for it. And I'm going to move it. I'm going to move a couple components around, actually. So let's say I want to move it. So one way is you could start moving it here, but then you're adding stuff to the timeline. I would say go back to the position back here in the timeline before you started doing before we started doing fillets, before we did a shell, any of that stuff. I'm going to double click on this like that, and that brings me back in time. And I can start moving this around. Now I don't have a reference of the drawing, but we can move it after we drew it. But I think for the sake of this tutorial, I'm just going to move it a little bit here. So let's say I want to move this. I'm going to click on, right click anywhere on the canvas, hit move, make sure, yep, object is selected, hover over my object, click on the object. Oh boy, it's slow. There we go. Took a minute. And then I can move it this way. It's okay if it's on top of that for now. And then I'll even move it up, dramatically up, just to show you the change. So I'm gonna move it like 6 millimeters up and hit OK. And then I'll right click, go to finish and capture position, and I will accept that position. So now what happened, right? How do I have to redraw my standoffs or anything? Take a look at that. The standoffs in the sketch is all derived from this board. So since I modified it in the past and I brought it forward, all of those features just followed through the timeline. And that is a very powerful thing. So when you're making enclosures with a bunch of different components, you want to keep that mentality, the notion of going back to when you did anything and updating it from there. Because when you carry those changes over to the beginning, over to the current, all of those things that you applied will carry over to that. And that is how I came up with what I have here now. I was able to sort out where I want things and then find a good position of it. So if I were to, this is the first case I made, by the way, just sort of going back to it so I don't have to spend so much time lagging with my computer. If I were to move this up, these openings here on the side of the enclosure would update. These are the USB ports. So if I wanted to move the component around, move it to a different surface or a different area of the enclosure, all of those edits would follow through. So that's basically all I wanted to cover in the tutorial. This is my first iteration of the enclosure. I haven't printed it out or tested it anyway. This is just part one of, I think, a couple more series that we're going to do with this project. I still got a little bit to go. I'm going to set up CAM tools, which is setting up the tool paths that will be necessary for not 3D printing, but for milling on the other mill. And I want to start doing that as soon as I figure out all the things for the 3D printing part. So that's just part one of the tutorial, and just wanted to share with you guys just a little bit about capturing position using your timeline, and a little bit of sketching here and there, and creating extrudes, of course. So that's about all I'm going to cover in this tutorial. I'm actually going to take a look at the chat here, since I haven't been able to this whole time. And if anybody has any questions, I will be happy to answer them. And if I can't, I'll ask some of our folks and see if they can answer. So, guys in the chat, somebody's asking if can I see the chat. Yeah, I'm sorry, I wasn't able to see the chat at first because I just wanted to get through the tutorial. Yep, looks like to be the case. My hair is fabulous. That's funny. Yeah, I'm having one of those awesome hair days. All right, guys. Well, I will catch up with you guys possibly tomorrow. I'm going to try to stream tomorrow. There is a scheduled maintenance update for Fusion, so hopefully I can get to you guys before then. Yep, this is a pretty fun and exciting project. Again, shout out to Todd Treese for writing this. I think I'm DJing now. Yeah, like we said, there's still a little bit to do with it. You know what? I think it's because my Wi-Fi is just like killing the bandwidth. And you can see here in Terminal what it's downloading, what programs it's downloaded. We're also going to have a version where you can use your arrow keys or your keyboard to control the radio station. So again, it's just like pause and play and some volume things. So that's pretty much it, guys. Again, if you want to check out the GitHub, it is github.com/Adafruit, NPR1_Raspberry Pi. Still working on it, but just wanted to share that with you guys. Also, check out Todd Treese on Instagram. He goes by the handle Uniontown Labs. Uniontown Labs. He's got a very, very adorable set of dogs, some doggies. Doing a lot of woodworking stuff, combining woodworking and electronics. Here's actually a little bit of the NPR logo that he milled on his X-Carve. So that's pretty cool. Very awesome. Again, shout out to you, sir, for collaborating with me on this project. It's very fun. Okay, that's it for the stream. Thank you guys so much for hanging out on this Pi Day Friday. Appreciate you guys coming in, jamming out with me. I know we have a little bit of problems with the stream because of the lagginess and the fusions and stuff, but that's what happens with live streams. So you just got to get through it and push through it all. Again, guys, I will see you hopefully tomorrow. Oops, I don't need to do that yet. Oh no, it's not working yet. Okay, cool. I'm just trying to plan out the end of the stream thing here. So, all right, guys, I will see you next time. Thank you guys again. I will see you next time. Bye, everybody.